Part A then of question 4, given that y equals 5x squared plus 3x minus 4, find dy dx from first principles. So here's the equation here, it's a little quadratic, and dy dx from first principles. So here, we need to write down the definition first of all, don't we? So dy dx is equal to the lim as h tends to 0 of f x plus h minus the f of x all over h. There's our definition. So that's equal to then the lim as h tends to 0 of fx plus h. So write this down with x plus h as the input value. So it's 5, that input squared, plus 3 times the input, minus 4, and the input is x plus h, isn't it? That's the first part then, that's that done. Minus, and there's more than one term, so put a bracket, fx, which is 5x squared, plus 3x minus 4, all over then h, which equals then h tends to 0. Expand this bracket, x squared, yeah, because it's just a quadratic bracket, so to speak. So you get 5x squared. 2xh times 5 is 10. xh, and there's an h squared, isn't there? The last term times 5 is 5h squared. Plus, expand this bracket now, 3x is the first term. Plus the second term, 3h. Minus 4, and now run the minus through these three terms, so it would be minus 5x squared. Minus plus, minus and a plus is a minus, 3x. And then the last thing is minus times a minus is a plus 4. Okay, there we go. All over h, which equals then, it's the limit as h tends to 0. Now let's see what we can cancel out before we write anything more down. So, what can we write? What can we cross out? The 5x squared and the minus 5x squared, they can cancel. We've got 10, what have we got? We've got a 3x and a minus 3x, agreed? We've got a minus 4 and a plus 4, they can go as well. So we're left with just 3 terms, all of which have an h in common, don't they? So we can take an h outside a bracket so that we can cancel with what's underneath. So let's take the h outside the bracket then. This term will just leave 10x, won't it? Once you've taken the h off. Here you'll be left with 5 lots of h. So you've taken one of the h's off there. And then it's plus 3. Okay, and underneath we've got our h, of course, which equals, the h's can cancel, so I'll just cancel them easily. 10x plus 5h plus 3, limit as h tends to 0. Well, this will go to 0, and we'll just be left with 10x plus 3. There we go. And that's what you would have expected to get, wouldn't you, when you differentiate this? 10x to the 1 plus x goes to 1, 3 lots of 1 is 3. So that looks fine. Good.